Hi everybody, welcome to another lesson with Mrs. John, and we are back in lockdown today, and this is the lesson for Wednesday the 12th of August. The first thing that I'm going to do is take you through questions 4 and 5 under voltage and current. So we've been working through these questions yesterday. We kind of got as far as questions 4 and 5. So I'm just going to talk you through them because the concepts are important, and these could lead to quite easy, simple explanation answers, which could possibly even lead to excellence. So it's really important you understand these ones. So I've drawn the question, the diagram on the board, and so here is a circuit with, it's got one lamp in series with the source, and these are your two parallel branches. Which lamp will have the greatest current? That is your question A. Explain which lamp has the greatest current. The greatest current is what's drawn from the battery, so lamp A will have the greatest current. Which one will have the smallest current? The smallest current, now all the current comes out of here and it splits into two, but it doesn't split into two halves because this lower branch has got greater resistance, so less current is going to go through the lower branch. So the least current is going to go through this lower branch, which contains lamps C and D. Now, between which two points is the resistance the greatest? I would say between points P and Q, because it's got the resistance of the whole circuit. And between which two points is the resistance the least? So it would be that, because that's got bigger resistance, right? Okay. Then which lamp has the greatest voltage across it? Now voltage is current times resistance, so whichever lamp has the greatest current through it, because the resistances are the same, that will also have the greatest voltage. So A has the biggest current, so it will also have the biggest voltage across it. Which has the least voltage? The one with the least current, which is the bottom branch. And since the resistances are the same of C and D, they'll all have the same voltage, but it'll be less than all the other voltages. Okay, if an extra lamp is added between Q and S, explain what would happen to the current from the source and the voltage across B. So Q and S is over here. So if you added an extra lamp, what's going to happen is you've added another lamp in series with the source. So that means the total resistance of the circuit is going to increase. If the total resistance of the circuit is going to increase, it means that the current drawn from the battery is going to decrease. Okay, and then what's going to happen to the voltage across B? So because the current drawn from this decreases, it's going to get a smaller proportion of the current. So this is going to decrease as well, the voltage across B. Now let's move on to question 5. So in the circuit, the lamps are identical. The meaning of the word identical is that the resistance of the lamps are all the same. Now, how do the brightness of the lamps compare with each other? Explain your answer in terms of the current through and the voltage across each lamp. So lamp A will have the biggest current through it, so it will also have the biggest voltage across it. Now the brightness of a lamp depends on its power output, which is a product of voltage times current. Now since A has got the biggest current and the biggest voltage, it will be the brightest lamp because it's got the biggest power output. Okay, so, and then it says an extra lamp D is connected in parallel to C. So I'm just going to draw an extra lamp here. So this is D, this is connected in parallel to C. So you get one more branch. So would the total resistance increase, decrease, or stay the same? So when you have more branches in parallel, there are more pathways for the current. So the resistance is going to decrease. The resistance comes down. Explain how this would affect the brightness of lamp A. Now that's your lamp A. Now remember, the brightness depends on current and voltage. Okay. Now, because the total resistance has decreased, it's going to draw more current from the battery, and all that current passes through A. So the current through A is going to increase. If the current through A is going to increase, but the resistance of A is the same, V is equal to I times R, so the voltage across A is going to increase as well. So what's going to happen to the brightness of lamp A? A is going to get even brighter. So I hope you understood those two questions. That's questions 4 and 5 from the page on voltage and current. Okay, and I'm going to make a second video on how to calculate total resistance. So both these things are for today's lesson. Bye for now.